Remember, sometimes less truly is more. Great recommendations feel personal and timely. Computer vision that literally saves lives. Pipeline components. Data ingestion from multiple cameras, LiDAR and radar. Object detection for cars, pedestrians, signs, and lanes. Tracking to follow objects across frames. Decision-making for path planning and control. Like having superhuman eyes that see everything, remember it all, and make split-second decisions. Critical requirements. Real-time processing under 100 milliseconds. High accuracy at 99.99% plus reliability. Edge computing to process in the vehicle. Fail-safe with graceful degradation. Now, let's look at the code example. This shows the basic structure of how an autonomous vehicle processes visual information in real time. Every millisecond and every percentage point of accuracy matters, making customer service smarter and faster. System design. Core components include text preprocessing to clean, tokenize, normalize, intent classification for what does customer want, entity extraction for key information like product and dates, sentiment analysis for customer emotion level, and auto-routing to direct to right department. Like having a super smart receptionist who instantly understands every caller and connects them to exactly the right person. Scalability strategy. Processing millions of tickets includes batch processing to handle non-urgent tickets in batches, stream processing for real-time urgent issues, model optimization with smaller, faster models, and caching to store common patterns. Continuous learning includes learn from agent feedback, adapt to new product issues, and update classification categories. Now, let's look at the success metric section. Routing accuracy, response time, customer satisfaction, and agent efficiency. Smart NLP transforms customer experience. Catching the bad guys with smart algorithms. Real-time detection. Analyze transactions as they happen. Like a security guard who spots suspicious behavior instantly. Features include amount, location, time, merchant type, and user behavior patterns. Anomaly detection. Find unusual patterns that don't match normal behavior. Like noticing someone buying 50 phones at 3 a.m., clearly unusual. Methods include isolation forest, one-class SVM, and autoencoders. Graph analysis. Analyze networks of connected accounts and transactions. Like mapping criminal networks, fraudsters often work together. Techniques include community detection, centrality measures, and suspicious patterns. Balancing act. Minimize false positives while catching real fraud. Like airport security, catch bad guys without annoying good passengers. Strategy includes multi-layered approach with human review for edge cases. The goal is stopping fraud without stopping legitimate customers. Keeping customers happy before they leave. Feature engineering. Behavioral features include usage patterns, frequency changes, support ticket history, and payment patterns. Engagement features include time since last login, feature adoption rate, and social network activity. Like a relationship counselor who notices warning signs before couples break up. Real-time scoring. Streaming pipeline updates scores as behavior changes. Intervention triggers provide automatic alerts for high-risk customers. A/B testing tests retention strategies. Now, let's look at the code example. This shows how to build a system that automatically identifies customers at risk of leaving and triggers retention campaigns. Prevention is always better than winning back lost customers. Serving multiple customers with one smart platform. Architecture challenges. Isolation requirements include data isolation between tenants, compute resource isolation, model versioning per tenant, and security and access control. Like managing an apartment building, each tenant has their own space, but shares common infrastructure. Shared versus dedicated includes shared for cost-effective but harder isolation, dedicated for expensive but complete isolation, and hybrid for smart balance based on needs. Best practices. Resource management includes Kubernetes namespaces for isolation, resource quotas and limits, auto-scaling per tenant, and cost tracking and billing. Data strategy includes separate databases or schema-based isolation, encrypted data at rest and in transit, and audit trails for compliance. Now, Let's look at the golden rule section. Design for the strictest security requirements from day one, easier than retrofitting. Security and isolation are non-negotiable.